The level of carbon dioxide in the atmosphere reached record heights in May of 2019, just over 415 parts per million. Once CO2 reaches the atmosphere, it, along with the other greenhouse gases, traps outgoing radiation, resulting in the warming of the atmosphere. How can we combat rising levels of carbon dioxide? And how can we use aerosol science to help us understand and mitigate climate change? Let's take a look. I'm Kayane Dingilian, PhD candidate at The Ohio State University, and I'm going to talk to you about carbon capture. Carbon dioxide dominates the greenhouse gas emissions into the atmosphere. Direct emissions aren't the only source of CO2, however. Additional sources include the oxidation of methane and carbon monoxide. The collection of methods to prevent CO2 from entering the atmosphere and instead repurpose it elsewhere is known as carbon capture and storage. Let's take a look at some of the research that is being done on carbon capture.
Hi, my name is Yang Han, a chemical engineer and a research scientist working with Dr. Ho in the Ohio State University. So our group designs polymeric membranes to capture CO2 from coal-derived flue gases. So the flue gas will go to the membrane module and the CO2 will go across the membrane and coming out as high purity. So for this project, we're also working with a modeling group.
Hi, my name is Deng. I'm a PhD student co-advised by Dr. Ho and Dr. Lin. In our group, we use computational modeling to engineer polymeric membranes for carbon capture. This is a pressuring issue, and I would like to make my own contribution to solve it.
Supersonic separation has increased in popularity over the last several years as an alternative method of carbon capture. In order to function, however, it needs the backbone of fundamental aerosol research. That's where we come in. These here are supersonic nozzles, and we use them in our laboratory to study the nucleation properties of molecules. We essentially perform small-scale carbon capture in a controlled environment while being able to extract information about the process.
Hi, my name is Tong. I'm a PhD student and I work with Dr. Aerosol.
We use a variety of techniques to obtain information such as particle size, particle phase, particle shape, and anything else that we believe modelers and other researchers might find useful. When we tackle problems on a scale as large as carbon capture, we cannot do it alone. By integrating the aerosol sciences with those of other fields, not only can we enhance current methods of carbon capture, but also develop new tools and technologies. Thank you for watching.